Okay, so hello everybody and welcome to the introduction to Python. So what will we be learning? We'll be learning the Python programming language. So Python is a high-level programming language. It is used in a variety of software applications used by Google, robotics, machine learning. Python is a simple but effective language. And we'll first learn to code in Python by looking at the format and the syntax. You might be wondering what this high-level programming language mean. Basically just a fancy way of saying Python is a programming language that's very human readable. So who am I? So I'm a student researcher at Harvard LIT Labs. I'm an engineering support analyst at Skywatch. I'm developing study a startup that will be launching soon, and I'm looking for users, so more on that later. I'm a software dev at TioHacks. I was a TEDx speaker, and I'm going into grade 12. And yes, I do use Python at Skywatch, so it is pretty important. So what will you learn? The Python programming language, and not just coding, but concepts. So most programming languages you can easily translate your knowledge to different programming languages. So what you learn here, you won't just like, this is not only just with Python, but you can help learn like JavaScript, for example, or other programming languages. And this is concepts, yes, not just coding, concepts. And you'll also be tackling a problem set where you apply what you learned, and you'll also be building a cool speech recognition app. So setting up Python, if you're a new, complete beginner, use this link, great link, is replit/languages/python3. If you are somewhat experienced and you already have a text editor open, that is fine. And I'm just gonna pause right here so that everybody gets set up with this replit. I'll just copy link address. Okay. Does everybody have a text editor open somewhere to code? Okay. I'm gonna assume that you guys are good to go. So, what is syntax? So the syntax of a programming language is the structure and rules that represents and allows the programming language to work. For example, the syntax in any English sentence would be the punctuation. So syntax basically means the rules of that programming language. And we're gonna first start off, and I hope everybody has a Python file open, .py. We're gonna start off by creating a print statement. So what is a print statement? A print statement is literally a statement that prints things out. And the code below is a print statement. When we run this program, we are telling it to output the following in the quotes. So let me show an example. I have a text editor open. Hold up, let me show you right here. So I'm using Replit right now, an online IDE, integration developer environment, I believe it means. And right now we have it set to Python. So we can say print hello world. We run that. This is our console. Compiles and it prints out hello world. How cool is that? We can change it. Let's change it. Let's say like hi. Nice. Okay. Those are print statements. Not too complex. It's just you're telling it to output anything in the following quotes. So Python comments. So a comment is a programmer readable explanation or annotation in the source code of a computer program. They are added with the purpose of making the source code easier for humans to understand and are generally ignored by compilers and interpreters. So how do we, demonstrate this in Python? So a single line comment is representing using a hashtag. So hashtag hey, there, this is a comment. When we want to use multi-line comments, so we want like a paragraph of a comment, we use 3 quotes and we say, hello, this is a multi-line comment. And we close that. So let me show you. This print statement, I can add a comment to this print statement saying, this is a print statement. Right? We'll run this, still displays hi. This comment is not compiled. So let's say I didn't have this hashtag. that would be not so good because we'd be hitting errors. But if we put a hashtag in front, let's say we want to have a comment that's really long. How do we do that? So 3 quotes, anything in between is the paragraph. So blah, 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 blah. This, everything in here, everything within this triple quotes will not run. That was a multi-line comment. Okay. And so you may ask, why use comments? Okay. Because comments are pretty important. So I took grade 11, 12 computer science and grade 12 and 11. Comments help with explaining code. Let's say you have a very complex code base. Like this isn't you would not comment this. This is just a print statement. Like anybody can kind of understand that. But let's say, for example, you just have a long list of code, functions, different operations going on. You would want to comment that. And how you comment is keep it simple. So 3 rules for commenting is keeping it simple, concise, and understandable. So for example, if I had a function that did uploading or something like that, then I would put a comment above that function saying this function uploads images to AWS, something like that. Keep it simple and concise. Another tip for comments is do not add comments to everything. So if this is a print statement, do not add this is a print statement because that would be very obvious. Sometimes if you add too many comments, or too much of anything, it can become very distracting. So only add comments when necessary. Variables in Python. So variables are containers for storing data values. We're able to assign numbers and text to a variable. So x is equal to 5, y is equal to 2, z is equal to Bob. Here, x, we are just storing an integer value. This x variable, we're just assigning to the value 5. Y is equal to 2, z equal to Bob. Let's try that. So we can say x is equal to 5, y is equal to 2, and string var is equal to Bobby. We run this. And obviously nothing compiles because we have printed nothing. And we know these are valid variables because, well, we're not getting any errors. Well, let's say, how do we display these variables? Great question. And by the way, let me know if I'm going too fast or too slow. And if anybody has any questions, then please let me know. So let's print thing. So we learned that print statements, we can just add like quotes inside, but we can actually print variables. So we do this by calling the variable name. We say print x, print 5. Great. You can print this one, string var. Print Bobby. Nice. Okay. So naming variables. So turns out you cannot just name this 1x. We're going to get an error that you're not allowed to do that. Naming. A variable name must start with a letter or an underscore character. Is that true? Let's try it. That works. Okay. A variable name cannot start with a number as was shown. It will print out an error. A variable name can only contain alphanumeric characters and underscores, A to Z, 0 to 9, and underscore. Really? Let's try that. Yep. Nope. Oh, yes, and I will zoom in a little bit more. Awesome. Yes. So a variable name can only contain alphanumeric characters and underscores. If we add a percent sign, that will give us an error saying invalid syntax. Variable names are case sensitive. Age. These are spelled all the same, but you can see slight differences in them, but they are not the same. These are 3 different variables. So if I say, so literally, if I do x is equal to 5, say x, capital X is equal to 5. No, wait. Let's get rid of that. Let's say I want to print out this x variable. I cannot do capital X. That is wrong. It'll say x, yeah, this is not defined. But if I did lowercase x, it will now run. So pretty case sensitive, so be careful with that. Again, some more variables in Python, but this is a, I guess, a more unique example. Like they say what's going on there. We can say x, y, z is equal to 5, 2, and hey. You may be like, hold up, what's going on here? This is basically we're assigning multiple variables all at once. So we separate by commas. So x, y, separated by commas, and z are 3 different variables assigned to 5, 2, and hey, respectively. So, excuse me, x would have the value of 5, y would have the value of 2, z would have the value of hey. And we can also prove this by just printing them out. So we can just print out, for example, x should print out 5. Prints out 5. We can print out y. That's 2. Now z, we can, and then we'll say hey. Awesome. Yes, we can also combine variables. So we can do x plus y. X plus y. Let's see what happens. 7, because 5 plus 2 is 7. However, we cannot do x plus z. Yes, and you can see here type error, unsupported operand types for int and string. So like we can also, this is common sense, but you cannot do 2 plus hey. That kind of doesn't make sense. And you also cannot do an integer type. This is an integer type plus a string type because you're adding a text and a number, and that kind of doesn't make sense. So keep that in mind. Yes, so this is proving it again. If you do 5 plus John, it will give you an error. Data types in Python. So variables can store data of different types, and different types can do different things. Python has the following data types built in by default in these categories. String. So string is this type separated by quotes, just a hey. It's basically just text is a string. We have int, which stands for integers, so these numbers you see here, 2. We have a float, which is a decimal containing 2 or more decimals. We have a complex, which is, I think, a very large number. We have a list, which is basically an array. So what is a list? So we can have like my list is equal to, a list is represented by square brackets that should be located on the very right of your keyboard, I believe. And the list basically can store multiple values. So 1, 2, 3, 4, 5, separated by commas. So let's see this. Nice. We'll also be learning lists later on in the slideshows. We have a tuple, there's a range, and there's a dictionary. What's a dictionary? A dict is basically a dictionary. So what is a dictionary? Think about it like this. When you open an actual dictionary, there's a definition and the meaning of the definition, correct? A dictionary basically stores values in key value pairs. Key value pairs. So back to the dictionary analogy, the key would basically be the definition, right? For example, we're searching up like electronegativity. That would be the key. The value would be the value of that key, which would be, in our case, the actual meaning. The dictionary can be like, hey, semicolon, 12. And this wouldn't be my list, it'd be my dict. So as you can, oh yeah, my bad. So as you can see, it printed out the dictionary. So this is the key. Hey is our key, and 12 is our value. And you'll be like, wait, can we add more? Well, yes, we can. Separated by comma. And Boolean type is true or false. A bool. So we can have like, is t is equal to true. Print is true. True. And false. Oh, false. Spell that correctly. And I'm pretty sure you cannot do lowercase f. Did you see that? You cannot. That is not defined. So when you do true or false, make sure it's capital F and capital T. And look, it highlights blue. Awesome. That's what I love about IDEs. They like color code it. So yeah, if you do lowercase t, that'll. Yep, that's not allowed. Oh, what did I just do? I did the back button. Oh no, it just reset. That's fine. Okay. Finding data types in Python. So when we're finding different data types in Python, this is important because let's say you're trying to read data in Python, for example, but you don't know what type of data it is, right? This is important. When you're programming an application and you don't know the type of data it is, then that can change a lot of things, right? Because if you don't know the type of data and you accidentally misuse that type of data, then you can run into a lot of errors. So how can we identify this? So we can see here in this example right here, we have x is equal to 80. That's an integer type. And we can identify that type by doing print type of x variable. Do you see that? So we use the type keyword that gets the type of this variable x inside these brackets. And here's another example below. X, Y, Z is equal to Bob 2411 respectively, x being Bob, Y being 24, Z being 11. Print type of the variable Y, which would be 24. And what is the type of Y? That would be an int type. So we can try this out. So we can say x is equal to 80. We can print type keyword, type. So this thing right here, type bracket, that is how you, I guess, in Python, identify the type. And in between these brackets, you enter the variable you want to find the type of, in this case, x. You run this, you see it's a type of int. Did everyone witness that? Everybody's following along. Great. Okay, awesome. And if we did, for example, Bob, class of string. Yeah, this could be very helpful. Python number. So like I said, int or integer is a whole number, positive or negative without decimals of unlimited length. Float. Float or floating point numbers is a number, positive or negative, containing one or more decimals. So let's try that. Let's do 10.00. 10.0. That'd be a float because now it's a decimal. Basic operators. So basic operators basically being addition, subtraction, division, multiplication, exponent, floor division, and remainder. So let's say we have like x equals 10, y equals 5, y equals 4. We can do like, I don't know, x plus y, 14, x minus y, 6, x divided by y, 2.5, and so on. These are different operators we can do. Exponents, let's do this. Let's do that. 1,000, 10 to the power of 4. Lists in Python, which are basically arrays. So a list is a collection which is ordered and changeable. In Python, lists are written with square brackets and allows duplicate members. Arrays are used to store multiple values in a single variable. So we can see my list is equal to square brackets 1, 2, 3, 4, 8. As you can see, we can have different types of data types in here. We have a string data type with a bunch of number data types, and that is allowed. We can also print the list, which will print this whole thing out. And we can also, let's say we want a specific value in the list. We can do print my list index 0. And I know you might not be meaning, what does that mean? Well, I'm going to show you. So let's create a list. My list is equal to 1, 2, 3, 4, and hey, J. Okay, we'll just keep that. Oh, I spelled that wrong. My bad. We can do print my list. Let's see what happens. Yes, it just prints this out. Just prints out the list, no problem. Let's say we want to print 1. What we do is that we first call our variable, my list, right? Our variable. Square brackets. And in this square brackets, we want to give it the index value of which element we want to access. So you might be wondering, first let me show you. This will print out 1, the very first one. And you might be wondering, hold up, if it's 0, it shouldn't print out anything because there's nothing at position 0. Well, in programming, everything counts at 0. So this is the 0th index of this variable. It starts at 0, 1, 2, 3, 4. 0, 1, 2, 3. There are not 5, there are 4. It counts starting 0. 0 is the very first one. So remember that. Which is why if we do 0, 1, 2, 3, 4, and 5, let's say this imaginary thing right here, it'll give us an error. List is out of range. It does not exist. It's out of range. If you did 4, it'd work though. Prints out this one. 0, 1, 2, 3, 4. We're accessing specific elements using this type of indexing. Hopefully that is clear. Python lists, reassigning values. So in this example right here, we have test1 list, the list of test1. Test1 is equal to 1, 2, high. Test1 index 0, remember, we're getting this value 1, is equal to I am new here. Print test 0. So what's happening here? What's happening here is that we are getting the value of test index 0, which is 1, and reassigning a different value of I am new here. And if you print out test again, because we changed the value right here, it'll print I am new here instead, because we have changed the value of 1 to this. Is this true? Let's try it. Let's use just this list right here, right? Let's say my list 0 is equal to, we're changing 1, right? The 0th element of 1. We're changing this value now to string 1. Let's change it to new. We're now going to print our my list at index 0. New. Did you see that? And just to show that it did change, we'll print it before and after our reassign. You see, it first prints out here. Python runs from top to bottom. Remember that, top to bottom. So it says print 0 index 1, prints out 1. My list, we assign a new value of new, print it out, shows new again. So that's how we are reassigning values. Append in Python list. So the append method appends an element to the end of the list. Append means adding something as an attachment. So in this example right here, test2 is equal to 0, 1, hi, hey. Test2.append 4. What will that do? This will add this value 4 to the very end of the list right here. Like shove it in between right here. And if we print out test2 index 4, accessing the 4th element, 0, before it was 0, 1, 2, 3. If we didn't have test2.append and we just printed out the 4th element, it would give us an error because it doesn't exist. But because we now appended a new value 4, and we, I guess, shoved it in right here inside our list at the very end, it says 1, 0, 1, 2, 3, our new element 4. So print out 4. Let's try that. So using our current list we have right here, let's do my list dot the keyword append, the method append, hi. Okay, 0, 1, 2, 3, 4. This should be the 5th element now, right? Hi. Awesome. It added it to our list at the very end. Not the beginning, not the middle, the end. We are appending something to the end. Okay. Another example. Okay, so we have an empty array and we're appending 1, we're appending 2, we're appending hi. I can print my array. Let's try that. In fact, let's leave this empty. Print just my list, and we can say my list append 1, my list append 2. Hi 1, 2. First appends hi, adds hi. Then we append 1, adds 1. Then we append 2, 2 in that order, top to bottom. Hi 1, 2. Prints out my list, prints out everything that's been added. Hi 1, 2. Now, removing arrays list elements. So we can use the .pop method to remove an element from the array. So we can see here my array is equal to 1, 2, 3, 4. My array.pop 1. 0, 1. We are popping the 0. We're popping the 1 element. Print my array. So let's see what happens. My pop 1. Yes, so it popped the 1th index. 0, 1. Pops out 2. Let's add more. 3, 4, 5, 6, 7, 6, 7. Did you see that? It just popped out too. There's 1, 3, 4, 5, 6, 7. It just popped out the first 1th index. 0, 1. You know what? Let's pop out the last one. Let's pop out 7. 0, 1, 2, 3, 4, 5, 6. 7's gone. He got popped away, I guess. Okay. Pop method using lists. This is another example. 1, 2, 3, 4. We're popping the second index. 0, 1, 2. Should pop out 3. 3. Now, when we print out my array. Oh, that's great. Okay. So let's say we popped out, in this example, we popped out the second index. This guy. No, this guy, 3. 0, 1, 2. Now printing out the second element. 0, 1, 2. It should be printing out 4, right? Because we removed the third one, right? 0, 1, 2. Removed 3. We're printing out now the second index, 0, 1, 2. So it should now just print out 4. Because we removed 3, and basically the whole array just shrinks. And now there's only 2 elements. 4. It should print out 4. Now, you might be wondering, how do we get user input? Because that'd be pretty cool if we could get user input. Well, we use the input keyword. So we can say my input is equal to input. This is how you do it. Input, brackets, print my input. So let's try that. Let's try that. Okay, so we can say my input is equal to input. We can say print my input is blank because it makes me want to input something, and we have to click enter for it to work. So we can say hello. So what happened here? So this input basically allows us to input. Like as you can see here, I just entered hello, click enter. But it stores what we inputted, hello, into this my input variable. And then when we print out my input, it then prints out hello again. So this my input variable stores our input and prints it out. What happens if we didn't have this variable? This would give us an error, so remove that. That's it. Because we're not storing it, we're just getting the input. I just inputted something, click enter, nothing else happens. So that's what happens. So input and append. So we have an array, my array is equal to square brackets. Print enter value in your array. Gets our input, stores our input inside our variable my input. We say my array, our array, which is empty right now, dot append, we are adding something, my input. We are appending our input into this array. So whatever we input in this variable will be added to my array. Hopefully that's clear. So let's try that. We can say we can say just our empty, we can say a print statement, enter element that is to be added, appended to be exact. My input is equal to input. We're going to say array.append my input. Let's try that. Enter element that is to be appended. So we can say great. And it appends it to the array. But wait, we want to print out this array to show that it actually works. Great. You see, it prints out great in this array as a string. And you can see it's a string. By default, input stores it as a string element. Remember that. So if I run this again and I say 1, see how it's in quotes 1? By default, input stores as a string. And we'll learn later on how we can change this into a different data type. Custom input program. So this is just another example of the inputs. Print, enter opening sentence. My input equals input, stores that input. Enter name, my input equals input. And we can print my input plus my input name. So you can concatenate, this plus basically adds these strings together. And that's allowed because you can do string plus string, but you can't do integer plus string, right? So let's try that. We can say, first off, let's do enter. Let's tweak this example. Enter first name, right? Enter last name, and we need to change this variable because we can't have 2 variables with the same name. That's not allowed. So actually, let's do f name, first name, l name, last name. Print out f name plus l name. Enter first name Eric, the last name Sheen, Eric Sheen, but they're just squished together. Why? Because we're literally just adding them together. So how do we add a space in between? Well, we can just go like plus again, add a space literally with these quotes. Now there's a space in between. So that's how you use inputs. Hope everybody is doing great so far, understanding things easily. Calculator in Python. So this is where we change from string to integer. So we can do fnum, first number, is equal to int, wrapping around input, enter first number, second number, int, input, second number, bracket, print your output is answer is equal to fnum plus snum, are two numbers, and we're printing answer. And you might be like, hold up, what is this int doing outside wrapping this whole input around that? This is what we call casting. So casting is when we change one data type into another. So what happens here is that when we input something, so we input enter first number, and we input 1, before, when we did, for example, this by default stores in a string, right? So you can say enter first number this time. And this is where we can use our type thing again, right? Our type thing is very helpful. Fname. So we can stop it, rerun it, enter first number 1. Class string, do you see that? This input by default stores it as a string. But how can we change it so that, by the way, I can just include this inside the input as a message, right? So enter first number 1. Class string. How can we change this input into an integer? Great question. We wrap it, we do casting. Casting is when we change one data type into another. So we're gonna wrap it with an int. Do you see that? This was usually a string, we're wrapping it into an int. Now run it again. Class int. We are adding casting, we are converting this string data type into an integer data type, right here, using the int. Awesome. Which means we don't have to do input, we can just do 3, for example, right? We're casting this quotes 3 number, we're changing it into an int. Again, int, we've casted it. So using what we know of casting, enter first number, first, not f name, fnum. Naming is also important. You don't want it, like if you code and you do wrong naming conventions, it can be confusing for other people to read your code. Fnum, snum is equal to exact same thing here, except enter the second number. And we can now do ans equals answer, which is fnum plus snum. And we can now print answer. Let's see if that works. And I don't know what just happened, but no, I do not want that. 1, 2, prints out 3. This is all integer data types because we cast it using it. So final result should be also an int, right? Because we're only adding it. So that's that. Now, conditionals, which are if statements in Python. Conditionals are basically handling logic, which is like true or false. If statements in Python. So if B is greater, if you can see here, if B is greater than A, print B is greater than A. But we haven't defined B and A yet, which we will. I will show you in the example. And note, if you see here, I added an indentation, if you notice. I did not just press print against the same alignment as the if. Indentation in Python is very important. The print statement in this if statement is the child element of the parent if statement. So this print statement is under the if statement. As you can see, if I put this, if I don't add an indentation, it'll mean that they're two separate programs, but we want this print statement to be part of this if statement, so technically it's a child of this parent if statement, if that makes sense. So if statement with an input, input 1 is equal to input, we already know that, we just store the string input. If input 1, which we're storing, is equal to high, print high back, else print y. So what's happening? This is an if else statement. So we say, and it is what it's like basically saying. It's saying if this variable is equal to high, so if it's equal to high, print high back. Else, which means if it's not equal to high, just print high. And you can see I do double equal, not one equal. One equal is when we assign something. Double equal is when we compare things. So if I just did input 1 equal to high, that'd be incorrect because we're not assigning input 1 to high. And you can't really do that in if statement. That'd be pretty bad. So let's try this out. So we say user input is equal to input. You can say if user input is equal to high, print high to u2. I should just control. Not sure if I spelled that right. Indentation, remember. If I just did this, that's giving me an error. Expected an indented block. Indentation is very important. And you might be wondering, well, how on earth do I indent? There's a tab feature on your computer, like literally just tab, just click tab once, bam, creates an indent. Else, if it's not equal to I, so this is like, else statement is like, if this fails. So if this is true, basically the saying is if this is true, print this. Else is saying, if that fails, then just print out whatever else is here. And say print sad emoji. Oh, nope, we don't want that. Sad emoji. Oh, how can we keep doing that? So we want an input right now. You can say hi. Bonjour. We entered hi. This became true. This user input stores out hi. Prints out bonjour. Let's say if we don't. Bye. Sad. Okay. So that's if else statements. Again, if another if else statement example in Python, if a is equal to 20, b is equal to 45. If b is greater than a, or is 45 greater than 20? Yeah, I'm obviously. Print b is greater than a. Else print a is greater than b. So we already know what the outcome of that will be. Is everybody good so far? Okay. Else if statements in Python. If statement is to specify a block of code to be executed if a condition is true, right? This condition had to be true for this guy to run. Bonjour. The else if statement is used to specify a new condition if the first condition is false. The else statement is used to specify a block of code to be executed if all other conditions are false. Let's see an example. Input 1 equals input enter your message. We just input something. If input 1 is equal to hi, print hi back, right? That's exactly what we did here. We said print bonjour. Else if, we represent else if with elif. Input 1 is equal to wow, print wow back. Else print what's up. So what's going on here? So if we inputted, for example, wow, it will go through this if statement like this. If input 1 is equal to I, print I back. We inputted wow, it will not run this. So this fails. Now it goes on to the next one. Else if, another condition, else if input 1 is equal to wow, print wow back. And it'll go like, oh, this is true because we inputted wow, so printing wow back. But let's say we didn't input hi or wow. What will happen? It will go through this. Is input 1 equal to hi? No. Else if is input equal to wow? No. Else, just print what's up. Okay, so let's try that. Let's add an else if statement. Represented using keyword elif. Do not do, oh, what did I just do? Do not do else if, that's wrong. It's representing elif. Elif and then a new condition equal to by print by to u2. Okay. So it's loading. We're inputting something. Hi. Let's print out by to u2. You see that? It runs by to u2. So it went here and said, is user input equal to hi? Nope. Is equal to by? Yes. Let's say if it wasn't neither. I spelled that wrong. Sad emoji. Hopefully that made sense. Okay, custom input checker. So input 1 is equal to string with cast. We don't really need to cast in a string because there already is a string. I don't know why that's there. Or maybe it does do something below. I'm not sure. Okay. Takes it out input. Oh wait, that does make sense. Hold up. Because remember, account for all edge cases. What happens if they input a number 3? Wait, no, but it does. Yeah, we can just get rid of this. My bad. What am I saying? So input 1 is equal to input myArray. If myArray.count input 1, print hello to you too. Else print OK. What on earth is count? We are about to find out. So enter something. My list is equal to 1, 2, 3, 4, 5, and then we can do hey. And then if myArray.count input. If my list dot count user input, right? Because we're comparing user input. It's equal. myArray.count input 1. Oh wait, that is the whole condition. Print hello to you too. Else. Let's see what this does. Dot count. What dot count does is it goes through the array, looks for what we inputted, and say, does it exist in the array? Let's try that. By the way, we should add a space right here. So now there's a space. We say 1. Or not. Let's see. So the condition is testing whether or not our string input value is within the array, my array. We can do this by using the count method, which allows us to count inside our array and see if our input is already a value inside my array. Okay, let's do string. If mylist.count user input. Oh my god. If we input 1 as a string, of course it'll say sad emoji. Why? Because input stores as string, remember? By default, input store as string. So if I input 1, it won't print out bonjour. Because right now 1 right here is an integer value. Right? If we input 1, it won't store it as an integer value. Remember. Oh my god, I can't believe it. Input stores as string. So if I input 1 here, click enter, it'll store that 1 as a string like that. Does this if mylist.count user input, if this is true, basically saying we're going to count throughout array, see if what we inputted, which is 1 in this case, which will be 1, does this exist in the array? If it does, print bonjour. It does not. String 1 compared to integer 1 are not equal. This is a string type, this is an integer data type. So 1, of course 1 is saying it does not exist. But if we do int, for example, we cast it in an int, bonjour. There you go. So what happened is that we inputted 1, which by default input is a string, cast it in an int, converts the string to an integer value, 1. We say mylist.count, does 1 exist inside this mylist? Yes, it does, in the integer form. If you do not have this, which means that hey should exist then, right? Because by 3y's, I don't know why it's 3y's. Bonjour. There you go. Yeah, don't forget, input stores as string. So remember that. By default. While loops in Python. So we're going into loops now. A while loop in Python is used to iterate over a block as long as the test expression, which basically is as long as the condition is true. So a loop over and over a block of code if the condition is true. The while loop consists of a block of code and a condition/expression. This repeats until the condition/expression becomes false. So keep looping over and over until the expression we set becomes false, right? Because if it's false, it should just stop running now. Oh, skip the slide. Indentation and while loops are very important. Just in general, indentation in Python is very important, so be careful with indentation. Like if I suddenly didn't have this right here, yikes. Yep, it should have been indented block. So just be careful with indentation, just in general. Note, in programming, the counting starts at 0, like we learned. 0, 1, 2, 3, 4. That should be. This is also known as the index value. For example, when we count how many values are there in an array, we start at 0. 0, 1, 2, 3, 4, 5, 6, and so on. Example of a while loop in Python. So I is equal to 1. This variable I is just equal to 1. That's it. While I is less than or equal to 9, this is our condition. We use the keyword while, right? And then now our condition. I has to be less than or equal to 9. Print I. I plus equals 1. What is going on here? So let me show you. I is equal to 1. Was it 0? Yeah, let's do 1. It can be really anything you want. You can see while I is less than or equal to 9. Print the value of I. I, remember, indentation, indent once, I plus equal to 1. There you go. What just happened here? So, as you can see, we had an outside thing, I is equal to 1. This is just a variable, I is equal to 1. That's it. We use keyword while, which we're going to loop through. Remember, we indented this code because this code is part of this while loop, the child code of the while loop. I is less than or equal to 9. Is this condition true? Let's break this down. Is 1 less than or equal to 9? Well, obviously so, yes, 1 is less than or equal to 9. Print I. Prints out 1. I plus equals 1. Plus equals 1 just means we're adding 1 to I. So now I is equal to 2, technically, right? I is first set to 1, I plus equals 1. Now it's 2. Now it turns to 2. Now it goes back up to here to loop again. Is this condition 2? While I is less than or equal to, is 2 less than 9, right? Because we updated it here in the first one, first loop. Yep, it is. Print I, prints out 2. I plus equals 1 is again. I is input now, values updated 3. While I is less than or equal to 9, is 3 less than or equal to 9? Yep, prints out 3, adds again 4, 5, 6, 7, 8, 9. Now let's go to the very last one. Let's say it loops over and over, it keeps adding to I is equal to 9. While 9 is less than or equal to 9. Print 9. It will print out 9. Now it'll add 1, make this 10, while 10 is less than or equal to 9. Is that true? Is 10 less than or equal to 9? No. So we're going to stop. We're going to stop looping, which is why it does not print out 10. Can everyone give me a thumbs up if they understand that? Yes. If you have any questions or I need to clarify anything, please let me know. Awesome. I hope everybody understood that. So, a while loop example consists of the print increment statements. It is executed repeatedly until count is no longer less than or equal to 9, right? If it was 10, it will keep looping until this condition is false. Okay. Oh, yes. We have a quick question from somebody. In Python, when you're prompting for user input twice in the same file, is it okay to assign 2 different variables, same input twice? Is it okay to assign 2 different variables in the same method input twice? What do you mean by that? Can you give me an example? Oh, so do you kind of mean like, you have a question from somebody, this is great. Like, do you mean like, for example, x, y is equal to like, do you mean something like this? We could try that, let's try it. Nope, we are not allowed to do that, it looks like. Oh no, as in my input. Sure, let's try that. My input is equal to input, and input is equal to input. Okay, let's see if that works. Let's just see. Well, it isn't giving us any error, so I guess that's right. Although I would be confused, though. Oh, wait, no, you did this. Right, my bad. 1, 2. Okay, that's allowed, yeah. Okay, it looks like in Python, you can have the same name, right? Input, input. That is allowed, it looks like. That is allowed. As long as you don't do, like, input equal to input, because that means same method equals same method. What you're asking is, does it, like, override the first input? Nope, separate variables. This input shouldn't override this input. This input shouldn't override this input because we're storing it in different places. This is its own separate variable, so it stores this, whatever we input it in this variable, stores whatever we input into this variable. And we can actually try this by first printing out at the very end, my input, print input. Nothing overrides. If that was the case, then that'd be very, very troublesome. Okay, so my input, we're storing 10, right? So in my input, it should have 10. Now in the second input variable, we're storing another input, so we can have 11. And again, we're printing out my input, which is, again, 10. Print input, which we inputted 11, so it prints out 11. So nothing overwrites. Hopefully that answers your question. That is awesome. If you have any questions, please write them in the channel. Okay, so, yep, while loop execute will no longer less than or equal to 9. With each iteration, the current value of I is displayed and then increased by 1, right? In our while loop example, go back, Control Z, Control Z, Control Z, we kept adding 1, right? So remember, to increment I, we have to increment I or else the while loop will forever, right? If this did not exist, then 1 will forever be less than or equal to 9. If I ran this right now, it's loading forever. Look, it's not stopping. Because 1 will forever be equal to 9, so you have to increment, stop. You have to stop that before it destroys our computer. So remember to add I plus equals to 1, or even I plus equals to 2. It can be 2, 3, 4, 5. It can be anything. It can be, so it can be even like 9. Okay, I think that actually broke something. Hold up, guys. I'm gonna reload. Yes, we got a fresh new constant. Yeah, it just prints out 1, right? Because in this case, it says I is equal to 1 is 1 less than or equal to 9. Yep. Print I, which is 1, plus equals 9. So 1 plus 9 is now 10. Is 10 less than or equal to 9? No, so go stop. So just prints out 1. So you can increment it by different amounts. Yep. If you didn't have this, as you can see, it loaded forever because 1 will always be less. Okay. While loop with else statements. So we can combine a while loop and an else statement, which is pretty interesting. I is equal to 1, I is less than or equal to 10. No, I is just less than 10. Print I. Keep on printing, printing, printing. Else print I is no longer less than 10. So let's use our same example from last time, right? We can add an else statement. Remember, look what I did here, this while loop indentation code. This one is not indented though, because it's on the same level as this while loop. Print I is no longer part of. Oh, what am I writing? Is no longer less than equal. My spelling to 9. Jesus Christ. Okay. Yep. So let's forget about this else statement, for example. We know that after it goes over, and then we do at the very last loop when it's like equal to 9, current like is equal to 1, but like we increment over, and then I soon equal to 9, and we say is I less than or equal to 9. Yes, it is. Print 9 goes 10, right? In this period right here, when we while looped over and over, and I is equal to 10, we said while I is less than or equal to 9. Is 10 less than or equal to 9? No. Else, we have an else option. Print I is no longer less than or equal to 9, which is why printed I is no longer less than or equal to 9. Awesome. That's pretty cool. You can combine a while loop and an else statement. So We can add an else statement to a while loop. With the else statement, we can run the once the while loop condition is no longer true, right? So when this condition was no longer true, the else statement printed out. Looping through an array. Right, so colors, our array, is equal to red, green, blue, purple. I is equal to 0, while I is less than the len, new keyword here, len colors, print colors I plus equal to 1. So we're going to learn something new, something here. So we can say colors is equal to blue, purple, green. A while loop consists of a variable, I is equal to 0, for example, while I is less than the len of our array, the length of our array. Keyword len means the length. What is the length of this array? The length basically is just how many elements are in it. 1, 2, 3. The len colors basically means 0 is less than 3. Keep looping. Oh, what just happened? I guess I have to write that back. This will say while 0, which is I right now, less than 3. Is that true? If that's true, then we're looping. Right? And what did we do? We printed it out. We printed out each and every element. Colors I. And then we have to increment it, or is it loop forever? Bam. How does this work? So remember, if we start at 0, right? Because we want to access the 0th element. So while 0 is less than the length of the array, which is 1, 2, 3, right? The length is 3 right now. 3. Print colors I. And we already learned before in the slides that if we want to access a specific element in the array, we can access the array plus the index. But in this case, our index is the I variable that we are incrementing, which allows us to keep going through the array. Print I right now is 0. So first it will print out blue. It did that. I plus equals 1. This I variable is now equal to 1. While 1 is less than 3. Is 1 less than 3? Yes. Print colors, the first element, 1. Not right, because we updated it. 0, 1. Purple. Print out purple. Change it back. I plus equals 1. 2. Right? Is 2 less than 3? Yes. Print the color array's second index. 0, 1, 2. Green. Prints out 2. I plus equals 1, 3. Now this is where it stops. Is 3 less than 3? No. They're equal. We did not say I is less than or equal. We just said, is 3 less than 3? No. So we're going to stop. So that's how it prints out each and every element in this array. And remember, len gets the length of the array, whatever's inside these brackets, colors, which are 3. 1, 2, 3. Len just means how many elements are there. Did that make sense? Hopefully that made sense. Okay. Now we're going to do a more advanced example. So we have my array is equal to square brackets. Input 1 is equal to int. Input number of elements needed. Basically, our input here is casted into an int. I is equal to 0, while I is less than input 1. Right? Input 2 is equal to input value to go into our array.append input 2. Print the value has been added to the array. Plus equals 1. This is kind of hard to read on a slideshow, so let's code it out together. So we're starting with the empty array. This program is called the array add, let's say. And we can say len array is equal to int. We're casting an input. What? Oh my goodness. Oh, what is going on? No, I just want it here. How? Just say length of array. Oh, spelled length wrong. Length of array, right? I is equal to 0. While I is less than the len array, the length of our array, right? Array.append. Oh wait, no. We want to get also the length of the array. We want to now get new input, so we can say element is equal to input again. We want to add another input. Enter the value you want. We input something, right? We say array.append element. And then we can have a print statement saying we want to check that this element was actually added to the array, right? We can do that by saying element, comma, array, I has been added, right? I plus equals 1. Length. So first off, let's first understand what's going on. We have an empty array. We get the length. We want to input length of array. This is how long we want our array to eventually be, because we're going to loop through and add it, right? 3. So this value is now 3. Remember that. I starts at 0, while 0 is less than 3, right? That's basically what it's saying. Element is equal to input value 1. Let's say 1. Appends to the array what we inputted into here. It prints out array I, array 0 has been added. Element 1 has been added. So this has been added to the array. I plus equals 1. So now I is equal to 1. 0 plus 1 is 1. Again, 2. Element 2 has been added. I plus equals 1, 2, 3. Element 3 has been added. Plus 1, 3. Is 3 less than 3? No. Stops. So do you see here how we used inputs in a while loop to add to an empty array? Hope everybody understood this. Now, on to the next one. We can have a password guesser. This time using a while loop again. Let's see. Let's try to understand this code first, okay? Instead of coding and just saying, okay, it works. Password is equal to x51231123. That, by the way, that is not my password, so don't try and put it into any of my Gmail accounts. So while true, fguess, first guess, is equal to input, guess the password. While true basically means this will run forever, okay? While true, this means this will forever be true, right? True will always be true. This will run forever. Fguess is equal to input, guess the password. If fguess is equal to password, break. Okay, so this means that this will constantly run over and over until you get this password correct. So let's try. Cool little program building. Password equal to x, whatever you want. While true, we're gonna print out password. Okay. No, wait. What am I doing? Fguess is equal to input, guess password, right? Print fguess. No, wait. If fguess is equal to the password, right? Because we want to see if it's correct. Break. What does break do? This keyword break will break this loop, okay? So if you do break, if you do guess this password, this loop will just stop. Doesn't matter if it's constantly stopping. If you do break here, this will just break this loop. Let's try it. Guess the oh, you want a space in between. Stop, run again. Guess the password. 1. Oh, see here? You gotta name it properly. You're gonna get an error like me. Wrong. Loops forever. But if we copy this, breaks. That was a cool little program we built. Random in Python. So we can import random. Import random. Let's try it. What's random? We're importing random. What's the import keyword? We're basically random module. Oh, we don't want that. So this allows us to import a package to use this functionality from this random. Right. So my random number is equal to random.randint 0 to 10. So I believe this gets a random integer between 0 and 10. I'm pretty sure. If not, you can also search that up. So random int is equal to random.randint. Give it a range 0 to 10. Random. It will generate a random integer from. We can say print random int. Right? Let's try this. Each time we load, it should give us a random integer. I'm not 100% sure if it's inclusive or not inclusive. Guess we'll find out. 5, 3. So we keep 10 up. Guess it's inclusive because we've got 10. 4, 2, 3, 10, 2, 2, 5, 6, 8, 2, 2, 4, 7, 2, 0. Oh, I guess it is inclusive. 0 to 10 inclusive, guys. 7, 7. So you can see it gives us random variables. Do you see that? Pretty cool. So that's how you randomize stuff. Pretty interesting. Heads or tails program. Let's build a heads or tails program. Import random. We did that. Random option equals random or rand int 0 to 1. This will give us a random integer of either 0 or 1. So give us a random either 0 or 1. My option heads or tails. Print my options random option. So if it's 0, we're getting my options 0 heads. That's pretty cool. So let's try it. So array is equal to heads, tails. Okay. Random int, we want to generate 0 or 1, right? And now we want the array. Index random int. We want the index of this. So remember, this will generate 0, 1. Let's say it generates 1 on the first time. It'll get array 1, which is tails, 0, 1. And if it's 0, excuse me, then it'll get heads. Okay, so we say random int. Heads, 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 tails, 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 heads, 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 heads. Oh wow, heads is getting lucky. Tails, tails, tail. Oh my god, heads, 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 tails, heads. So that was a pretty cool heads or tails program. Did you see that, everybody? Hopefully everyone understood what we're doing there. For loops in Python. So there's another loop called for loop. A for loop is used for iterating over a sequence as either list or tuple, dictionary, set, or string. My list equals 1, 2, 3, 4, 5. For I in my list, print I. What is going on here? We used a for word keyword for I in my list, print I. So what is going on here? So we're saying for I in this case is representing each and every element in my list. For I in my list. My list, I, for each element in my list, print I. So before in a while loop, we had to do, remember before in a while loop, we had to do I is equal to 0 len array, right? And what we had to do was that we had to do print array I to access the 0th element, for example, right? In a for loop, we don't have to do array I. Okay, instead we can just do 1, 2, 3, 4, right? For I in array, print I. Let's see if this works. Wow, much simpler too. Array is equal to 1, 2, 3, 4. So what did it do? For I representing each one for I in array. Take this literally, don't overthink this. Just for I means element in array. So say 1, 2, 3, 4. For I, which is 1, print I. So I, 1, in my array. For each element in the array, basically is what this is saying. Print I, 1, 2, 3, 4. Don't overthink it, just means for each element in the array, just print I. I representing the actual element. So we don't have to do this, okay? That gives an error. Just do I, because I embodies the whole element itself now in a for loop. Hopefully that was clear. Did that make sense? Okay. Functions in Python. A function is a block of code which only runs when it is called. You can pass data known as parameters into a function. Function can return data as a result. In Python, a function is declared using the def keyword. Def add AB add numbers equal a plus b, return add numbers, print add 1, 3. What is going on here? So let me show you. Function is used by def. Remember, a function is just a block of code that'll execute when we call this function. The name of this function is add. Okay, remember that, add. By default, Python function looks like this. Def add, brackets, colon, and then whatever we want, the amount of code. Remember, indentation important. Hi. Run, nothing happens. Remember, a function must be called. It has to be called. Then it'll print hi. This is how we call a function. Remember that. But in this case, we can also pass in data into a function. Remember, a, b. Separated by commas, a, b. Print, let's print a plus b. Run gives us an error. Do you know why? Because we have to match this. We cannot just leave this empty. Okay, it requires, this function requires a and b. So let's input 10 and 10. 20. What happened here? We called this function def add, which takes in two different forms of data, a and b. We gave it to it, 10, 10. 10 being a, respectively, 10 being b. Print a, 10, plus b. We pass it in. But we're now returning it. So we can turn this to a variable. We say ands is equal to a plus b, return ands. What happens? Nothing happens because return doesn't print anything, returns it. We can print it. Let's print out the return of this function. 20. So what does this return do? The return statement causes your function to exit and hand back a value to its caller. The point of functions in general, so the point of a function in general, is to take in inputs and return something, right? It's best to return a value to this add function. In fact, we can set a variable x is equal to add, right? We're allowed to do this because it returns just one value, a plus b. And we can print out x. 20, still 20. No problem. The return statement is used when a function is ready to return a value to its call. It's ready to return a value. We calculate the answer, a plus b. That's it. If you want to simplify this code even more, you can literally get rid of this and say return a plus b. Still 20. Hopefully that made sense. Another example, def my function x. This time it's just x. We're returning 5 times x. 5 times x. So whatever we input as x, we can have 1. Add, we'll pass in value 1. 5 times 1 is just 5. Just 5. And we can call it as many times as we want. We can have like bam, 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 x, y, z, 2, 3. Oh, we're only printing x, that's why. X, y, z. Oh, whoa, what's going on? Y, z. 5, 10, 15. Yep. The first one calls it 1 times 5, 2 times 5, 10, 3 times 5, 15. Print it out. We can call a function as many times as we want. Classes and objects in Python. So Python is an object-oriented programming language. Whoa, you probably heard that cool term thrown around a lot. Object-oriented program basically just means this concepts of objects, like in the physical world, used in programming. Okay. So how do you initialize a class/object? Here we have class car, def init, underscore. I don't think you can see that. Let me see. Yeah, there's 2 underscores there, by the way, guys. My bad if that didn't show. Underscore init self wheel speed nitro. Oh wait, what? Oops. Right here. Class car def init self wheel speed. Self.wheels equals wheels, self.speed equals speed. Okay, first off, let me explain to you object-oriented programming, okay? Object-oriented programming is like using objects to describe it in like the programming world. For example, this is a car object, okay? This is a car object, and we can define different attributes of a car. So let me ask you this question. What does a car usually have? Well, a car usually has wheels, right? It has a speed. self.wheels equals wheels, self.speed equals speed. This init keyword is basically initializing this instance of a class, this class. This self keyword is using this instance of a class. Its wheels, dot wheels, the self dot wheels, this field, this attribute of this class, car, has wheels, dot wheels, is equal to the value pass in, wheels. Self dot speed, remember the car's speed, is equal to the value we pass in speed. So first, let me show you, okay? Class car, keyword class car. Remember, the object-oriented programming, kind of remember, like kind of like physical objects. Like this is an actual car, kind of, if you know what I mean. Hi, we have a question. Hi, have basic understanding of Python, but I'm not sure how to create a web. Will that be taught in this workshop? Not really. I mean, this is kind of introduction to Python. We're not doing web development using Python. I will be showing you how to do speech recognition, which is pretty cool, if you're interested in that. But no, not in this one. We will be not creating a web page. Sorry about that. Okay, class car, init, self keyword. This has to have a self. This every class has a self keyword. What does every car have? Remember, this is like an object, right? A real life object, a car object. What does it have? It has wheels, right? Every car has wheels, unless you're driving a floating car, which would be really cool. Okay, it has a speed as well. Oh, this function, my bad. It has speed. We do self dot wheels. The instance of this class is equal to wheels, the value passing. Indentation is important, guys. Indent 2 times self dot wheels. Self dot speed is equal to speed. Cool. We run it, nothing happens. So you might be wondering, okay, Eric, we have an object here, class a car object. What do we do with it now? Well, you can create a car object now. You can literally do car, treat it like a function, because remember, when we initialize this object, we need to pass in wheels and speed. How many wheels does a car have? 4. What's the speed? 10 kilometers per hour. But like, we don't do that. Nothing happens. X is equal to a car. Did you see that? We are now setting a variable equal to as if it was a car object with 4 wheels and a speed of 10. Cool. We cannot just do print.x because it'll just print out the object itself, which is like this weird stuff. So we can do x dot wheels. 4. Object-oriented programming, guys, at its finest. Class car. We have an object of a car. Okay. We have an initialization function. We have the self, which is just creating it with the attributes wheels and speed. Setting what we pass in, 4 and 10, as it. And then now that we created this with attributes 4 and 10, with the wheels, with attribute wheels equal to whatever we passed in, 4. Speed is equal to speed, what we pass in right here, 10, right? We created a car object fully, right? We met all the parameters because 2. X, this value x is equal to this almost like object-oriented programming is like as if it were a physical object in real world. Think about it like that. Don't overthink it. It's just called car object. A car. We print out x, this variable x, dot wheels. We gave it wheels. The attribute, a property of this class is wheels. We'll print out 4 because we gave it 4 wheels. If we gave it 3 wheels, we'll print out 3. So do you see how powerful objects are? And you might be asking, okay, what's the point of object? Well, it's used in game development a lot. It's used in everything. So let's say we have a character class. So I don't know what type of games you guys might play, but we can have like, let's try like Minecraft, right? A Minecraft character. Minecraft character? We'll just do player. Let's do player. Players will have an x and y coordinate. Properties. So before we create an object, we always have to think to ourselves, what properties does a player have? Well, properties have an x and y coordinate, right? In a game, a player moves like x, y, right? Pretend this is a 2D game. We want to update this perhaps, right? X, y. Players will have a speed depending on how fast you move. right? It can also have like a health bar, right? So we can update our x coordinate. Y. This is how B is starting. Self.speed equals speed. Self.health is equal to health. And now this is no longer a car object, it's a player object. XY coordinates, we can start at 0. Whoa, we did not want that. We can start at 0, 0. We can have a speed of 5, of 4, doesn't matter. We can have a health of 100. And now we can set this to player 1. We can say player 1, no longer wheels. Player 1 got health. Let's say we want to play 100. So do you see how powerful objects can be? It's like mimicking real life. It's like a video game. It's like we can have a player object which has health of 100. We can access this easily. And you can see in game development we have like loops, functions which check how much health that player has. We can update a object's health, for example. You can see how powerful this can become. Objects can become very useful just with simple attributes. Properties of this class. So hopefully that made sense. And I'm going to teach you a concept called inheritance. Inheritance, as a simple term, literally means inherit. So for example, the car class, we can create a child class such as Toyota, I create another, that will inherit properties of the parent class of car. Let's go back to car, right? We can have, this is like the parent class, okay? Car is the most top level generic class you can get, right? Let's get more specific. Let's create a class of Toyota, okay? And this time in the parameters, because this one didn't, we have car. This now takes in the properties of this, okay? There you go. And now we have in itself, wheels, speed, nitro. Same thing. Remember, it inherits the same properties of the parent class, inclusive. But instead we have car.init, self, wheels, speed. So what's going on here? Speed. But then we also added our own field called nitro. Remember, we can also add our own fields. This child class will inherit all fields, right? It will initialize it based on this, right? Car class will initialize it. Self.init, right? It'll do this, basically. But we added an extra field to nitro. Self.nitro to nitro. So let's create a Toyota class. Remember, so inheritance, the concept of inheritance is that we have a parent class, which is a car, right? But we want a more specific child class, Toyota. It will inherit it. Remember, each car has a wheels and speed, right? Every car has a wheels and speed. But Toyota might have something different. So it might have nitro. So we create an extra field, excuse me, called nitro. Toyota 410 boost. We can have like 100. Okay. Oh, whoops, I didn't remember semicolon, guys. Be careful of that. Oh, what's going on here? Line 9. So, oh, whoops, car. My bad. Yep, my bad. We have to initialize it through the car, remember? It inherits properties, so car.initialize self real speed, right? My bad. It's not self. That didn't make sense. Remember, car.init, self wheel speed. And then we have an extra feature called self.nitro equals nitro. So you can see here that we added nitro, an extra field, not part of this car class. Remember, we inherited properties. We inherited properties of wheels and speed here, but adding an extra feature called nitro, which we give it 100. So we can say this Toyota car, is equal to x dot. Oh, no. Toyota object dot to nitro. It should print out 100, right? Okay. 100. There you go. This is inheritance. Epic. So this concept of inheritance is not only Python, maybe in JavaScript, Java. So a great concept to know is literally to inherit. We create a child class such as Toyota that will inherit properties of class. Remember, so this car is very generic, just wheel speed. Every car has wheels and speed. We want to get more specific. We want to create a Toyota class. For example, they have like nitro on top of this car. Hell, it can even have wings. Okay. What time is it? Okay, so first off, let's do a time check. Leo, how much? Because I might think about skipping this problem set and immediately going to speech recognition. It's 9:30. Do we have till 10 o'clock? Okay, let's go. Let's just do the speech recognition then. I think we want to get this project going. So, I will mention in the before slide, which was just a problem, is that remember to stop and think. Okay? Good programmers don't just immediately start coding. Stop and think about the question or whatever problem you're solving. Like whatever you're coding in general. If you're going to structure a program or anything you're coding, don't just immediately go to, okay, we need to create a function. Blah, blah, blah. Stop and think. Okay? Don't just rush into coding. Stop and think. Write some pseudocode. Pseudocode is like you can have them comments like human readable saying, here we have a function for uploading. You might need that, right? Here we might need another function looping through characters, right? This is pseudocode. Stop and think. Write some pseudocode. Logically come to a solution, okay? And think out loud while you're doing it. When given a problem, a coding problem of any sort, or you're just building an application at a hackathon, don't just immediately start coding like crazy, or else you can make a lot of mistakes along. So make sure, just in general, if you're starting out a hackathon, have an idea, kind of, like have a structure of like understanding which tech stack you're, how you're going to structure the code, what type of problems you might run into, how you're going to structure, for example, the architecture of the code, for example, database connections or whatnot. And if you have a Python file and you have specific functions, don't just immediately go into like start rushing into coding, just immediately spam code, just generate code. You wanna think about it. You wanna stop and think, logically think about what you're doing, and say, okay, I need to build this type of function. Does that make sense? Right? You don't just want to rush into coding, eventually make a lot of mistakes and like, oh wait, I shouldn't have done that because I went. Stop and think. Is always good. So just a tip, just in general about programming, don't just rush into coding. Just stop, think, kind of formulate your thoughts, and just come to a logical solution. Okay. So now we're going to build speech recognition using Python. So for this one, I don't have an answer created, right? Because for this, I'll not just be showing you the answer, but instead showing you how I research, understand, achieve, build this in hackathons. In hackathons, you'll need to build research and Googling skills for typing. That is the end of the slideshow. So let's do it. Let's do it right now. So first off, I'm going to log into login. Continue with, hopefully all of you guys off. We create a new Python program. Name of replit 10. Oh my, that's randomly generated. Speech record. Create replit. Let's do speech recognition in Python. How do we do it? So if you don't know what to do, Google it. Literally, speech recognition using Python. Remember, I didn't prepare for this, right? I'm doing this right in front of you. Yeah, this looks legit. And notice how Google searching is important. Notice how I didn't do how to do, like, don't do that. Just do straight to the point, quick Google search speech recognition in Python. Quick to the point. Oh wait, there's a towards data science thing. Let's click this, April 6, 2020, so we know it's not too outdated. Remember, also look at the date, because if you're in a hackathon, if you're coding something and you're looking at like April 7th, 2014 or 16, like 4 years ago, 5 years ago, you might want to look at a link that So just keep that date in mind. So 2020 was just like not too long. Blah, blah, blah. Okay, so we got some code to come. No, I'm kidding. Actually, not really. Pip install speech recognition. What is pip? Good question. Pip is how we download packages. So pip is a package management system written in Python used to install and manage software packages. First off, so basically this just download packages. What is a package? Programming. Remember, we don't want the definition of programming. A package of namespaces that organize self-related classes. Package is a collection of files, directories required for a software product, and is usually designed and built by application developer after completing development of application code. So basically, a package is basically a bunch of files containing code wrapped up into a package that we can use and download, right? That's the point of our package. That's why we need install this speech recognition package to use speech recognition, right? Because in Python, by default, we don't, by default in Python, we don't have speech recognition available, sadly. So we have to install a package to help us with that. So let's do this. So let's go to, hoping you using replit or something like that. Let's go to shell, okay? Pip install, speech recognition. We're downloading this package. Collecting it, downloading. Awesome, looks like we're using that should be fine though. Okay, let's see steps. Import speech recognition library. Initializing, recognize a class in order to recognize speech recognition. Audio files supported by speech recognition, blah, blah, blah. These are formats available. I have used taken movie, which says, I don't know. By default, Google recognize a region clip. It supports the different languages. For detailed, please check this documentation. Let's check out the scope. Import speech recognition as SR. So what's going on here? We're importing the speech recognition library, right? That we installed from here. That's how we're even able to import. If I didn't install this speech recognition, it won't identify it because we didn't download it. So import speech recognition as SR. SR just means we're too tired to type this whole long thing out. So just import it as SR. So r.sr equals recognizer. So initializing recognizer speech. Okay, I can live with that. Remember, the point here isn't to understand how does this work. So like I'm not questioning how does recognizer work? Like what are the inner workings, right? That's not for me to really understand. I just kind of at a surface level, I understand this is how we initialize a recognizer class. It looks like you stored it in the variable r, okay? Reading audio file as a source. And look, notice how it's using const. These are great. Listening the audio file and store it. So with sr.r, I don't know. As source, audio text equals r.listen source. Looks like he's using, okay, sr.audio file. Remember, I don't need to fully understand it. I just know it's audio. I don't know .wave. Looks like he's listening to this as source. He's just doing audio text is equal to r.listen source. Looks like r.listen listens to this source, right? Because this is the source. Recognize method will throw a request error if the API is unreachable, hence using exception handling. Try catch. This is just a try except using Google speech recognition. Text equal r to recognize Google audio text per text. So this is not what we're looking for. Oh, this is what we want. Microphone speech into text. Remember, what this was doing, how I noticed was that this is listening to this audio file and converting it to text. Right now, what we want to do is do speech to text, right? I want to talk text. So that's how you quickly skim to, like, I'm breaking this all down for you, but as you like look at review more code, do a skim through, you'll understand that, hey, this is not microphone speech to text into text. Okay, this should be low. So you install this package, PyAudio. PyAudio library, which is receive audio input microphone speaker, basically helps get a voice to go. Makes sense. Instead of audio file source, we use the microphone class, right? So we don't use an audio file source like above example. Let's do that. First, though, I need to download this. Downloading. Let's just wait for it to load. In the meantime, let's look at this code. Same speech recognition, recognizer class with sr.microphone initializing as source, print talk. Audio text, we will listen source. We are now accessing this microphone class, listening to, which is our source, and listening to it. Print timeable thanks. Try print text to go r.recognize Google text. We'll now try to translate whatever we said, right? Because our microphone is on. We access the microphone as our source. We listen to it. We store what we said. Let's try to convert it now to text. And yes, I did just copy that. Awesome. Okay, let's shrink this. Now let's run this. Let's see if it works. Kind of basically have a basic understanding of what's going on. Try except basically means literally as it is. Try this. If it doesn't work, print out, sorry, I did not get that. Literally try except, that's what it means. Whoa. What's going on here? Let's see. Let's debug. Hello. What's this talk about? Hello. 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 Okay, it looks like I can't do this through Reddit. So I'm gonna open my VS Code. Okay, I'm gonna open my VS Code and do it, guys. Let's try it through VS Code. Okay. Let's try speech. Okay. Oh, and accidentally open something. Right. Let's try this on our VS Code. Save that, run it. Let's see what happens. Now it works. Okay, Replit is not very. Okay. Hello, my name is Eric Sheen. Okay, remove this print. Did you see that, everybody? I'm not sure if you got that. I'm not sure if you. Does VS Code Command Plus work? Oh, it does. Awesome. Okay, we enlarged it. So let's run it again. Hello, my name is Eric Sheen. Okay, as you can see, it's not very accurate. There you go. Speech recognition using Python. And all it took was a quick Google search and just quickly trying to understand. Notice how I did copy this code, but I didn't just copy it, right? I didn't just blindly copy. I kind of looked at it, kind of understood it. Notice I was using a microphone class, listening to a microphone as printing time over thanks. Then trying to print out our text, recognizing it using the Google recognizer, using the audio text variable we stored our voice into. And if it can't recognize it or something goes wrong, we just print out sorry tonight. I did not practice for this. This is just a link I stumbled on. I'm just showing you how I research, understand, and achieve this result. Just for a quick prototyping. So yeah. Oh yeah, and you guys probably want this code, right? So let me just print that into the workshop dev chat as a code block. Okay. So let's try it again. This is really cool. Hello, hello, hello. Nice. Nice. We can also try new things. Now that we know this, try something. You know what? Let's try. Since we know r.recognize text, if r.recognize text equal to 5, print 5 out. Let's see if this works. Okay. experimentation is very important. Let's see if this. Hi. No. Oh wait, it does lowercase hi. Okay, let's try that. Hi. Whoa. Hi back. Pretty cool. So we can even create cool. This says like, how are you? Say, I am good. How are you? Right? How are you? That is really cool. So you guys are how I did that. So yeah, that is a quick project on speak recognition using Python. And thank you for listening. So what time is it? That's around. We ended pretty well. So I hope you got something from the presentation. It's not only the coding, but the concepts that you have learned. Hopefully use this knowledge in a good way in your projects. And I hope you change the world somehow. Build upon this. Thank you for listening. That's a new presentation. Yeah. So, do you guys have any questions? Or it doesn't have to be this related presentation. You can hack related questions. Excuse me. And yep, that wraps it up. Yeah. No problem. God help. And also, I am building. Oh, sorry. I'm building a startup called Study. So Study is basically allows users to input text, upload documents, URLs, anything, and it will basically translate all of that into summarizations, keywords. And right now, we're launching soon, and it'd be awesome if I'm looking for users, so you can join the Discord or follow us on LinkedIn. So I'll be posting that. I create a Discord community.